R is a language which was developed by statisticians for statisticians. So if you want to perform any sort of statistical analysis, then R should be your go-to language. And R also provides more than 10,000 packages for different purposes. So if you want to do data manipulation, then R provides a package for that. If you want to do data visualization, then R also provides a package for that. So whatever your task is, R provides a package from its hat. And also, R is one of the most widely used languages to implement data science and machine learning concepts. Hey guys, I welcome you all to this session on R programming for beginners. So now that we've understood the importance of R, let's go ahead and start off with the session. So before I actually start off, I'd like to tell you guys that we have come up with a free learning platform called as Great Learning Academy, where we offer more than 80 courses with respect to different domains such as artificial intelligence, data science, machine learning, cloud computing, digital marketing, and so on. The link for which you can find it in the description. So you guys can go ahead and check out what exactly is Great Learning Academy. Now let's have a quick glance at the agenda. We'll start off by installing R and RStudio in our systems, and then we'll look at some basics of R. After that, we'll look at the different data structures in R, which will be vector, list, metrics, and data frame. Then we'll work with inbuilt functions in R. After that, we'll work with flow control statements, and then we'll see how to do user-defined functions in R. Then we'll see how to do data manipulation in R with the dpyr package, and then we'll see how to perform data visualization with the ggplot2 package. And finally, there will also be a case study where we'll be working on the Pokemon dataset. So let's just start off with the session.
So we'll start by installing R, and you can install R from this particular site over here. So we've got cran.rproject.org. So let me just click on this link over here. Let me just wait till this loads up. Right. So we've got different versions of R. So if you're using a Linux system, then you can download R for Linux. If you're using a Mac system, then you can download R for Mac. And if you're using a Windows system, then you can download R for Windows. And since I'm using a Windows system, I'll be downloading R for Windows. So I'll click on this link. All right. So again, we have this option to install R for the first time. I'll click on this. And this is the latest version of R, R 3.6.1 for Windows. I'll click on download and the download would start. Now, after installing R, we would also need an IDE. So IDE basically gives you certain features so that implementing code becomes much easier. So if you have worked with Java, then you would know that there is an IDE for Java called as Eclipse. So analogous to that, we also have something known as RStudio when it comes to R. So RStudio is the IDE which makes coding with R extremely easy. And to download RStudio, you can go to this particular site over here, rstudio.com. So I'll click on this link. Alright, so this is the site, and over here we'll be basically downloading the free version of it. So I'll click on download, and we've got different versions over here again. So if you're using a Ubuntu system, you can download it for Ubuntu. Then we've got Debian, Fedora, and so on. And since I'm using a Windows system, so I'll download the 64-bit version for the Windows system. Right. So now the download for R and RStudio is complete. Now let's turn to the programming part. So we'll start by understanding what exactly are variables in R. So simply put, variables are just temporary storage spaces. So let's take this example to understand variables in a better way. So you see this shopping bag over here. Now consider that you can only store one item in the shopping bag at one particular time, right? So what you do is you have the shopping bag with you, you go ahead and buy a phone, and then you take this phone and place this inside the shopping bag. So over here, this is your variable and you are storing this particular data item, which is a phone, inside the shopping bag. So after some time, you decide that you don't need a phone and you actually need a pen. So you take this phone out and you put this pen inside this shopping bag over here. And again, after a while, you decide that you don't actually need a pen and you need a makeup kit. So again, you take out this pen from the shopping bag and then you place this makeup kit inside the shopping bag. So over here, this shopping bag is basically acting as a variable. So first it stores a mobile phone, and then it stores a pen, and then it stores a makeup kit. So this is what exactly is a variable. It stores temporary values inside it. Now going ahead, we'll work with these variables in RStudio. So this is RStudio, guys, and we've got all of these panes over here. So this is the script window where you can write all of your script. This is the console window where you can execute your code. And then we've got the environment window over here, which basically shows you the different variables you have. And then we've got this packages and plot window. So this basically shows you the different packages which are already installed, and you can have a glance at all of the plots in this plots window. Right, so let's go ahead and see an example of variables. So I'll go ahead and create a variable with the name var1, and inside this I will store the value, let's say phone. Now I'll print this out, var1, right? So the value is phone. Now what I'll do is inside var1 again, I will store the value pen. Now let me print out var1 over here. So initially the value stored inside var1 was phone, and then I change this value to pen, and when I print it out, the value is pen. So this is how a variable works. So it basically stores temporary values, and you can change that value whenever you want. So again, I will go ahead and change this value. So instead of pen, I will store, let's say, makeup inside this. Now I'll print this again, right? So now the value of var1 is makeup. So this is how variables work in R. Now every variable is basically associated with a data type, and every data can be of different types. So data can be of numeric. So if you got numbers such as 3.14, 75 and 500, this is basically numeric data type. And then we also have character data types over here. So if you have names such as Sam and Bob, or if you say sentences like I love pizza or my name is Sam, so this is basically character data type. And then we've got the logical data type, where you basically have two values. First value is true, and then the second value is false. And then finally we've got the complex data type, and in complex data type you have two parts. First is the real part, and then you have the imaginary part. So over here we've got numbers such as 7 plus 5i and minus 3 minus 9i. So in 7 plus 5i, 7 represents the real part and 5i represents the imaginary part. So these are the different data types which can be present in R. Now again, let's go back to RStudio and work with some data types. So I'll clear this out. Now again, I'll take a variable with the name var1. I'll put in equal to, and let me store a numeric value inside this. So I'll store, let's say 12.34, and then let me print this out, var1. Now let me check the class of it. So class of var1. So inside the class function, I am passing on this variable1 object, and you see that the class of this variable is basically numeric. Now in this var1, what I'll do is I will basically store a character value. So inside this, now I'll store, let's say Sam, and then I'll print out var1 over here. Now let me check the class of it. So class of var1. Right, so initially when we had given a numerical type to this var1, the class was numeric. After some time, when we went ahead and stored the value Sam inside var1, the class changed to character. So the class of the variable basically depends on the type of the data which you store inside this variable. So if you given a numeric type data inside the variable, the class of the variable would be numeric. If you given a character type data inside the variable, the class of the variable would be character. Similarly, if you given a logical type data inside the variable, then the class of the variable would be logical. So that is what we're going to do now. So I'll type var1 over here, and inside this, let me give in a logical value. So I'll type in true over here. And when it comes to logical values, in R you have to keep in mind that all of the letters have to be capital. So TRUE, all of the letters have to be capital. Now let me check the class. So class of var1. Right, so we see that this is logical now. Now finally I'll store a complex value inside this. So var1 equals to, I'll say 13 plus 6i. Now let me check the class of it. So class of var1. So see that this is complex. So these are different data types which can be present in R. Now going ahead, we'll work with operators in R. So these are the different types of operators in R. We've got assignment operators, arithmetic operators, relational operators, and logical operators. So we'll be starting with assignment operators. So with the help of assignment operators, we can basically assign a value to a particular variable or a particular function, right? So this is what assignment operators are used for. So let's say I have a variable with the name A, and I want to assign a value to this. Now there are three varieties of assignment operators. First is the equal to operator. So I'll just give in the equal to value, and I'll store the value 8 inside this. So what I'm basically doing is I am storing the value 8 inside this variable A. Now let me print this out, right? So we see that we have assigned the value 8 to A. Now I have another variable with the name B, and I will use the second type of assignment operator. So this time I am using a less than symbol, and after that I am giving a hyphen, and then I'll store another value inside this. So let's say I given the value hello. Now let me print this out. Right, so now I have assigned the value hello to the variable b with this assignment operator. And then finally we have the third assignment operator where we actually given the value first. So I'll given the value which is true, and then I given this assignment operator. So over here I given the hyphen first, and then I given the greater than symbol, and then I'll given the name of the variable where I want to store. So I want to store this in, let's say, final. Alright, now I'll print out final over here. So we have successfully stored the value true inside final. So I'll just print out all of these three assignment operators. First is the equal to operator, and then we've got this operator over here where we given less than symbol, and then we given hyphen, and then we've got the third assignment operator where we given hyphen, and then we given the greater than symbol over here. So after the assignment operators, we've got the arithmetic operators, and arithmetic operators are used to perform simple mathematical functions such as addition, subtraction, multiplication, and division. So we'll see an example of each of these. Now for doing that, I'll basically create two variables over here. In the first variable, which is num1, I'll store the value 10, and then I'll go ahead and create the second variable with the name num2, and inside this I will store 20. So now I've got my variables over here. Going ahead, I'll perform some mathematical operations upon these two variables. So let me just print out these two variables in the console first. Right, so I have successfully created num1 and num2. Now I'll type in num1 plus num2. I'll copy this and I'll paste it over here, and we get the result 30, because when you add 10 and 20 you get the result 30. Now similarly I'll perform the next operation over here, which would be num1 minus num2, because when you perform 10 minus 20 you get a value of minus 10. Now I'll perform the multiplication operation, so it would be num1 into num2, and when you perform 10 into 20 you get a value of 200. And then finally we'll perform the division operation, which would be num1 divided by num2, and you get a value of 0.5, because 10 divided by 20 is 1 by 2. So these are some of the basic arithmetic operations which you can perform. So next up we have the relational operators. In relational operators we've got these symbols over here. So you've got greater than symbol, you've got less than symbol, you've got double equal to, and you've got not equal to over here. Now again for this, let me just use the same numbers of num1 and num2. So I'll type in num1 equals 10, and then I'll type in num2 equals 20. I'll copy these two variables and I'll paste them over here. Now let me start off with the greater than symbol. So I'll type in num1, and then I'll put in the greater than symbol, and then I'll give in the second variable, which is num2. So I'm basically checking over here if num1 is greater than num2. So we get a false value. Now we get a false value because num1 is actually less than num2, or in other words, 10 is actually less than 20. Going ahead, we'll use the second relational operator, which is less than. So now we are checking if num1 is less than num2. And we get a true value because 10 is actually less than 20. Going ahead, we have the double equal to operator. So over here, I'll put in double equal to. So with the help of double equal to operator, we are checking if the values stored in both of the variables are equal or not. Again, I'll hit enter. So we get a false value because 10 is obviously not equal to 20. And then finally, we have the not equal to operator. So the not equal to operator is given like this. You given the exclamation symbol, and then you given the equal to operator. And then we get a true value because 10 is obviously not equal to 20. So these are some of the relational operators. Going ahead, we'll work with logical operators. And to work with logical operators, we'll create two more variables. So I'll create a variable with the name log1, and I'll store, let's say, true in this. And then I'll create another variable with the name log2, and I'll store false in this. Alright, so I've got my two variables ready. Let me execute them first. So I've got log1 and log2 ready. And the two logical operators which we have are basically AND and OR operators. So let's understand a bit about the AND operator and the OR operator. So the AND operator basically gives a true value if both of the operands are actually true. So let's understand this over here. So over here, I'll type in log1 and log1. So we know that the value stored in log1 is true. So when you say true and true, you get a true value. Now let me type in log1 and log2. We get a false value because true and false become false. Similarly, let me type in log2 and log1. Again, we get a false value because both of them have to be true. But over here, log2 is false. Now let me type in log2 and log2. Again, we get a false value because both of the operands have a false value in them. So when it comes to the AND operator, we have a true value only when both of the operands are equal to true. So OR operator gives a true value when any of the operands has a true value, and it gives a false only when both of the operands have a false value. So again, let's understand this with an example. So log1, I'll give in the OR operator, and then I'll type in log1. So true or true. So we get a true value, obviously. And then I'll type in log1 or log2, which basically comes to true or false, which is true again. Now I'll type in log2 or log1, again get a true value. And finally, let me type log2 or log2. Now since log2 is false, so we are basically trying to check if false or false. And since both of the operands are false, we get a false value over here. So these are the logical operators. So just a quick info. If you're looking forward to pursue a post-graduation course in the field of data analytics, then Great Learning offers the Business Analytics and Business Intelligence program in collaboration with McComm School of Business at University of Texas Austin and Great Lakes, India. The faculty pool comprises of leading academicians and industry practitioners in the field of data analytics. And you can check out the course details in the description mentioned below. Now we come to the main part of R, where we'll be learning about the different types of data structures in R. So we've got vector, list, matrix, array, factor, and data frame. And we'll be starting off with the simplest data structure in R, which is basically a vector. So a vector is a linear homogeneous data structure. Now, what do I mean by a linear homogeneous data structure? It is called a linear data structure because it has just one dimension. And it is called a homogeneous data structure because you can store elements of only one particular type in this data structure. So let's go to RStudio and perform some examples with vector. So let's go ahead and create our first vector over here. So I'll give the name of the vector as vec1. And to create a vector, you would have to use this C operator, which basically stands for the combine operator. And inside this, I'll give in some values. So I'll give in all the numerical values over here, 1, 2, 3. I'll copy this and I'll paste it over here. Now let me print vec1. So see that this is a linear data structure which has only numerical values present in it. Now let me check the class of it. Class of vec1. Right, so this is numeric. Now let me create a character vector. So I'll type in vec2 over here, and inside this I'll type in A, B, and C. Now let me copy it and paste it over here. Right, so let me also print vec2. So we see that this is a character vector which comprises of the elements A, B, and C. So class of vec2. So we see that this is of character type. Alright, now I'll go ahead and create a logical vector with the name vec3. And inside this, I'll be storing some true or false values. So I'll type in true, false, and true. I'll select this and I'll paste it over here. Right, so this is a logical vector which has these three values, true, false, and trues. Let me also check the class of it. So class of vec3 is logical. Now let me do something interesting. What I'll do is I will create a vector which would have both numerical values and logical values present in it. Now let me actually do something interesting. So now I'll actually create a vector which would comprise of both numerical values and logical values. And I'll name this vector as mixbag1. So let me give in the values inside this. So the first element would be 1, second element would be true, and then I'll give in 2, and then I'll give in false over here. So now let me go ahead and print this vector over here. So this has actually been executed. But at the beginning, I've told you guys that a vector can only comprise of homogeneous values. But this vector with the name mixbag1 has heterogeneous values, which are basically numbers and logical values. So how has this vector even been executed? So to understand that, let me actually print out the elements which are present in this vector. So over here you see that these logical values have been coerced into numeric. So this element 1 is 1 over here. True has been coerced into the number 1. 2 is 2, and this value false has been converted into the number 0. So when you put in numbers and logical values into the same vector, the logical values are basically coerced or converted into numbers. And that is why we only have homogeneous elements in this vector over here. So even though we are passing in heterogeneous elements, they are being converted into homogeneous. And over here, there is greater precedence for numeric values than logical values. So that is why all of the logical values have been converted to numeric. Now let me create a similar vector where I'll be storing the numeric values along with the character values over here. So I'll type 1, A, 2, B, and then I'll also type in 3 over here. And I'll actually name this to be mixbag2. Let me change the name to be equal to mixbag2 over here and let me print it out. Alright. Now what do you think would be the answer? So let me just print it out and show you the result. So over here we see that these numeric values have been coerced into character. So this number 1 has been converted into a character 1. This number 2 has been converted into a character 2, and this number 3 has been converted into a character 3. Now to confirm it, let me also check the class of it. So I'll type in class of mixbag2, and we see that this is of type character. So when it comes to numeric values and character values, then character values take higher precedence over numeric values. And then let me create one final vector where I'm basically storing all the numeric values, character values, and the logical values in the same vector. And I will name this as mixbag3, and inside this I'll type 1, and then I'll type in A, and then I'll give in the value true over here. Then I'll type in 2, and then I'll type in B, and then let me give in the value false. So this vector has numeric elements, logical elements, and character elements. Mixbag3. Now let me print this out. So this time we see that all of the elements have been converted into character. So this means that character has the highest precedence, then it is numeric values, and then it is the logical values. So first is character, then comes numeric values, then come the logical values. Again, let me check the class. So class of mixbag3, and we see that this is of type character. Right. So we have this mixbag3 with us. Now what I'll do is I'll actually try to extract some individual elements from this entire vector. So let's say if I only want the second element from this entire vector. So let me try to extract the second element. So the name of the vector is mixbag3. To extract the element, we have this indexing operation. So we'll give in parenthesis, we'll give in this square braces over here, and then I'll give in the index number. And when it comes to R, the indexing starts with 1. So this is element which is present at index 1, and then this is element which is present at index 2. True is the element which is present at index number 3. So if I want the element which is present at index number 2, inside this I'll type in 2. So I have successfully extracted A from this entire vector. Similarly, if I want to extract this last element over here, so this is 1, 2, 3, 4, 5, 6. So element which is present at index number 6. So first I'll give in the name of the vector which is mixbag3, and inside the parenthesis I will give in the index number which is 6. So we see that we have extracted false. Now if you wanted to extract a series of values over here, so let's say I wanted all values starting from true and then going on till B. So this is starting from index number 3 going on till index number 5. So first I'll have to give in the name of the vector. Inside parenthesis I'll give in the starting index number which is 3. After that I'll give in colon, and after that I'll give in the ending index number which is 5. Right, so I've extracted true, 2 and B. And then if you wanted to extract some random index values from this vector, so let's say I wanted to extract only the first element and the last element from this entire vector. So for that you'll give in the name of the vector, you'll give in parenthesis over here, and inside this you will use in the combine operator, and inside the combine operator you will give in the index values. So I want the element which is present at first index, and then the last index, which is basically 6. So I have successfully extracted the element which is present at first index and also the element which is present at the last index. And this is how we can create vectors and extract individual elements from vectors. So this was the first and the simplest data structure, which was basically a vector. Now we'll head on to the second data structure, which is list. So a list is a linear homogeneous data structure. Now a linear homogeneous data structure basically means that it is present in only one dimension, and the data types which go into this data structure could be of multiple types. So a list can store, let's say, a numeric value, a character value, and a logical value, and these individual elements will retain their identity. So let's create our first list, and I'll given the name of the list to be L1. And to create a list, we'll be using the list function. Now inside this, I'll give in the element. So the first element is the number 1, and then I'll give in the second element, which is the character A, and then I'll give in the third element, which is basically the logical value true. I'll copy this and I'll paste it over here. Alright, so we have created this list. Now let me check the class of this. So class, inside this, I'll pass in the object L1. So we see that this is of type list. Now let me check the class of the individual elements of this list. So I'll actually print out L1 over here. So we see that we've got 3 different components over here, and these 3 different components have their identities maintained. So 1 is a numeric value and it is retained as a numeric value. A is a character value and it is retained as a character value, and true is a logical value and it is retained as a logical value. So just to be sure, I'll use the class function and I'll check the class of all of these individual elements. So I'll type in class. Inside this, I'll type in L1. Now to get the individual entities, you would have to give in double braces over here. So you'll type in double braces, and then to get the first component, you'll type in 1. So you see that 1 is of type numeric. And then I'll go to the second component, which is basically present at index number 2. So we see that A is of type character. After that, I'll give in the third index value. So see that this is of type logical because the value is true. So we see that in a list, the identities or the individual identities of all the elements is retained. Now let me go ahead and create another list where I basically have 3 vectors inside this list. So I'll type in list. The first component would be basically a vector which would comprise of all the numerical values. The second component would be another vector which would comprise of all the character values. So it'll be A, B, and C. And then we've got the third vector over here, which would comprise of all the logical values. So it'll be true, false, and true. Let me print this out. So this is L2 over here, which comprises of 3 components. The first component is a numerical vector, the second component is a character vector, and the third component is a logical vector. Now let's go ahead and extract some individual entities or elements from this entire list. Now let's say I'd want to extract this element C from this entire list L2. So this is the third element of the second component. So this is how we can extract. I'll type in the name of the list, which is L2, and then I'll give in double braces. Now inside the double braces, I'd have to give in the component number, which is 2. After that, I'll give in braces again, and then I'd have to give in the element index in the second component. So the element index is 3. So we have extracted C from this entire list. Similarly, if I had to extract this false value from the entire list, so this is the element at index 2 of the third component. So let me just print out L2 again. Now I'll type in L2, I'll give in 2 braces over here, and this is the third component. I'll type in 3, and inside the third component, this is the second element. Right, so I have extracted false from this entire list. So vector and list were the 2 basic linear data structures. And now we'll head on to the multidimensional data structures. So we'll start off with matrix, which is basically a 2-dimensional data structure. So it is actually a 2-dimensional homogeneous data structure which comprises of rows and columns. Now let me create the first matrix. I'll type in M1 over here. And to create a matrix, we have this matrix function. And I'll just pass in some values over here. So I'll use the combine operator and I'll pass in all of the elements from, let's say, 1 to 6. I'll take this. I'll I'll copy it and I'll paste it over here. Right, so we have created a matrix where all of the elements are basically present in different rows. So we have a 1 column 6 row matrix, or it is a 6 cross 1 matrix. Now this is not ideally what we want. We actually want a matrix which would have some number of rows and some number of columns. So to do that, we have the n row attribute inside this matrix function. So this is the same function over here, matrix. The first parameter is basically the vector which would give in all of the elements. Now after this, I have the n row parameter where I set the number of rows to be equal to 2. And then I have the n col parameter where I set the number of columns to be equal to 3. So I am creating a 2 cross 3 matrix over here. M1. So we have a 2 cross 3 matrix where we have 1, 3, 5 in the first row and 2, 4, 6 in the second row. Now if you look at this matrix, you see that these elements are arranged column wise. So you have 1, 2, and then you have 3, 4, and then you have 5, 6. But what if I wanted to arrange these elements row wise? So for that purpose, we have the by row attribute. So I'll type in by row and I'll set the value to be equal to true. Now let me print out M1. So this time we have these elements arranged in the row wise order. So by default, these elements are arranged in column wise order. And if you want to arrange them in row wise order, then we have to set the by row attribute to be equal to true. Now let me go ahead and extract some individual elements from this matrix. So now I want to extract this element 5 or this value 5 from this matrix. So I'll type in M1, I'll give in parenthesis over here. And this value 5 is present at row number 2 and column number 2. So I'll type in 2, 2 and I have extracted 5. Similarly, if I wanted this 3 over here, this is present at row number 1 and column number 3. So I'll type in M1, I'll give in the row number which is 1 and then I'll give in the column number which is 3. Right, so we have extracted the element 3 from this entire matrix. Now we'll head on to the next type of data structure, which is basically array. So you can consider array to be just an extension to matrix. So matrix is a two-dimensional homogeneous data structure, while an array is a multi-dimensional homogeneous data structure. Now before we create the array, we'll actually create two numerical vectors. I'll create vec1, which would have, let's say, all the elements starting from 1 to 6. So 1, 2, 3, 4, 5, and 6. And then I'll create the next vector, which is vec2, which would have all the elements starting from 7 to 12. So 7, 8, 9, 10, 11, and 12. Now let me print out these two. So I've got these two numerical vectors ready. Now I'll go ahead and create my array. So I'll type in A1, and to create an array, we would have this array function. And inside this array, the first parameter which would be giving in would be the data. And the data is basically coming in from these two vectors. So I'll combine these two vectors over here. And to combine these two vectors, I'll use the C operator. And inside this, I'll pass in vec1 and vec2. So I've given the data. Now after this, I would have to set the number of dimensions over here. So I'll type in dim to set the number of dimensions. You can consider array to be basically matrices which are stacked on top of each other. Now what I want to do is I basically want to create two matrices of the size 2 cross 3 which are stacked on top of each other. So let me repeat this again. I want to create an array which would comprise of two matrices of the size 2 cross 3. So over here, the dimensions would actually be 2, 3, 2. So this means that I am creating an array which is of two dimensions, and in those two dimensions, the size of the matrix is 2 cross 3. So let me copy it and let me paste it over here. Let me print A1, and this is what we have. So we have created an array which comprises of two matrices, and the size of both of these matrices is 2 cross 3. And we have 12 elements in total, right? So 2 cross 3 into 2 gives you 12 elements. Now let's see how can we extract individual elements from this entire array. So I want to extract this element 11 from this array. So this is present in the second matrix, and the row number is 1 and the column number is 3. So I'll give in the name of the array first, which is A1. I'll put in these two commas, and then first I'll give in the matrix number of the dimension number. So it is 2. and then I'll set in the row number, which is 1, and then I'll set in the column number, which is 3. So I have extracted this element value 11 from this entire array. Now we'll head on to the next type of data structure, which is basically a factor. So you can consider a factor to be a data structure which holds categorical values. Now factor variables or categorical variables become very important during the model building process. So let's actually understand about it. So to create a factor, all you have to do is type in factor over here, and inside this I'll create a character vector. So let's say I create a character vector with these 3 colors. I'll type in blue, and then I've got yellow over here, and then the next color which I have is red, and I'll store this in a new object and name that object to be color. So let me print this out. So we have basically created a factor object which comprises of these 3 categories, which are blue, yellow and red. Now let me actually repeat these colors and let's see what would be the result. So we've got blue, yellow, red. So I'll add yellow 2 more times over here. Let me print out color again. Right. So this time these are all the elements: blue, yellow, red, yellow, yellow. But if you look at the levels, you see that the levels remain the same. We've got blue, we've got red, and we've got yellow. So this is how you can work with categorical variables or factors in R. And then we've finally got a data frame. So a data frame is a 2-dimensional heterogeneous data structure in the form of rows and columns. And this is the most important data structure when it comes to R, because you'll be implementing most of the data manipulation and data visualization operations on this data structure called as data frame. So let's go ahead and actually create a data frame. So to create a data frame, you would be using this data.frame function. And I want to create a data frame which would comprise of 2 columns. The first column is basically the name of the fruit, and the second column is basically the cost of the fruit. So let me create the first column, which would be fruit name, and the values to this column would be basically coming from this particular vector over here. So the names of the fruits are apple, banana, and then we've also got an orange. So this is the fruit name, and then let me go ahead and give in the fruit cost as well. So this would be my second column over here, fruit cost. So let's say apple costs around $100, and then we've got banana, which costs $50, and then we've got an orange, which is in between, and that costs $75. So over here we are basically creating a data frame which has 2 columns. So the first column is fruit name, and the second column is fruit cost. Now let me store this in a new object and name that object to be fruit. I'll copy it and I'll paste it over here. Let me run this. Alright. So you can actually have a glance at the data frame with the help of this view function. So I'll type in view, and inside this I'll pass in the object which is fruit. So we have created this data frame which has these 2 columns, fruit name and fruit cost. So we've got this data frame with us. Now let's see how can we extract individual columns. So first we'll give in the name of the data frame, which is fruit, and then I'll give in the dollar symbol, and then I'll give in the name of the column. So let's say if I want to extract only the fruit name column, I'll select fruit name. So first the name of the data frame, and then the dollar symbol, and then the name of the column. So this is how we can extract the first column from this data frame. Similarly, if I want to extract the fruit cost column, so over here I'll select fruit cost, and then we have extracted the second column from this entire data frame. So extracting a column from a data frame is extremely simple. All you have to do is give in the name of the data frame, then the dollar symbol, and then the name of the column. So these were all of the data structures which were present in R. So we've looked at vector, list, matrix, data frame, and array. Now let's go ahead and work with some inbuilt functions. So we'll look at all of these different inbuilt functions over here. And we'll be working with all of those inbuilt functions on top of the iris dataset. And as I've already told you, to have a glance at the dataset, we'll be using the view function. So I'll type view of iris. So this iris dataset basically comprises of 5 columns in total, which are sepal length, sepal width, petal width, and species. Now this dataset basically comprises of the 3 species of the iris flower, which are setosa, versicolor, and virginica. And we've got the corresponding sepal length, sepal width, petal length, and petal width corresponding to those 3 species. Alright. Now let's work with those inbuilt functions. So the first inbuilt function was the structure function. So all you have to do is type in str, and inside this I will pass in the data frame, which is iris, and this gives you the entire structure of the data frame. So over here this tells you that there are 150 observations of 5 variables, or in other words there are 150 rows in this data frame and 5 columns in this data frame. And then you also have a bit of description about each column. So you see that sepal length is a numerical column, and these are some of the first few values in this column. And then we've got sepal width, which is also a numerical column. Then we have petal length and petal width, which are also numerical columns. And then finally we have the species column, which is basically a factor variable with 3 levels. So this is why the structure function is used. So after structure, we've got the head function. So with the help of the head function, we can have a glance at the first 6 records of this data frame. So inside this, I will pass in the name of the data frame, which is iris. So we've got the first 6 records of this data frame over here. Similarly, if you want to have a glance at the first 10 records, then all you have to do is using n over here and then given the value 10. And then you can have a glance at the first 10 records of this entire data frame. So similar to the head function, we've also got the tail function, with which you can have a glance at the last 6 records of this data frame. So first, all you have to do is pass in the name of the data frame inside this, and these are the last 6 records which are present in this iris data frame. So starting from row number 145 going on till row number 150, and these are the last 6 records present in this data frame. Similarly, if I want to have a glance at the last 10 records of this data frame, I'll use n equals and then I'll pass in 10 inside this, and these are the last 10 records which are present in this data frame. And then we have the table function. So table function is used to identify the frequency of the categorical columns, or to understand the count of different levels which are present in a categorical column. So I'll type in table, and the only categorical column which is present in this iris data frame is the species column. So I'll select the species column, iris $species, and we see that there are 50 entries of Setosa, 50 entries of versicolor, and 50 entries of virginica. So this is how table function can be used to get the frequency of each of the different levels of a categorical column. Next, we've got some arithmetic functions. So we've got min, max, mean, and range. So if you want to find out the minimum value in a particular column or a particular vector, then we can use the min function. So inside the min function, what I'm doing is I'll pass in this sepal length column. So I want to find out the minimum value of sepal length. Iris $sepal length. So we see that the minimum value of sepal length is 4.3. And then I'd want to find out the maximum value of sepal width. So to find out the maximum value, I'll use the max function. And inside this, I'll pass in iris $sepal width. And the maximum value of sepal width comes out to be 4.4. And now I'd want to have a glance at the mean of petal length column, or the average petal length of the different records which are present in this data frame. So I'll type in mean iris $petal length, and the mean petal length value comes out to be 3.758. And then we've got the range function, which basically gives you the minimum value and the maximum value, which is basically the range. So I'd want to find out the range of this petal width column. So I'll type in range, and inside this I'll type iris $petal width. And we see that the minimum value of petal width is 0.1 and the maximum value of petal width is 2.5. So these were some of the inbuilt functions in R. So next we have decision making statements. So with the help of decision making statements, we basically given a condition, and on the basis of that condition, we make a decision. So we've got if and if else. So let's start with the if statement. And again, we'll be working with the same iris dataset to implement the if statement. So let me open a new script window over here. Now I actually want to make a condition where I am checking if the first cell value in the sepal length column is greater than 4. So I'll type in if, and I'll put in braces over here. So this is basically curved braces over here. And inside this, I'll give in the condition, which is iris $sepal length. And since this is the first cell in the sepal length column, I'll use in parenthesis and I'll type in 1. Now after this, the condition is I want this value to be greater than 4. So if the value is greater than 4, then I'd want to do something. So I'll just print out the sepal length is greater than 4. I'll copy this and I'll paste it over here. And we see this result, the sepal length is greater than 4. So this is how the if condition works. So we give in a condition, and if that condition is evaluated to true, then we go ahead and perform an action. And if that condition is evaluated false, then nothing happens. So over here, what I'll do is I'll actually change this condition. So this time I want to check if the value which is present in the first cell is less than 4. And if it is less than 4, do something. So I'll copy this. I'll paste it over here. And we see that we don't get any result. And this condition actually fails because sepal length is greater than 4 and not less than 4. And that is why we don't get any result over here. Right? So when we gave in the first condition where we checked if sepal length is greater than 4, it was evaluated to true and then we got the result. But then again, when we used less than symbol instead of the greater than symbol, this condition evaluated to false because obviously the sepal length is greater than 4. So that is why nothing happened. So this is where the if else statement comes in. So first we use the if statement, and then if it evaluates to true, we do something else. Now this else checks that if the if condition fails, then do something else. Now this might seem complicated, so let me just give an example to you guys over here. So I'll type in if, and then I'll give in the first condition iris $sepal length, and then the first cell, if it is less than 4, then you'd have to print out sepal length is less than 4. After this, you'll give in the else condition, and then you'll type print sepal length is greater than 4. Now let me print it out over here. So we get this result, sepal length is greater than 4. So this is how this statement basically works. It starts with the if condition and checks if the sepal length, this particular record, the value present in this record is less than 4. And if it is true, do this. And since this has been evaluated to false, it does not execute this and comes to the else statement, and then it prints out sepal length is greater than 4. Now the looping statements are basically used to repeat a particular task. And today we are going to look at the for loop and the while loop. So we'll start with the for loop. So the for loop is used to iterate over a particular list or a sequence of items. So let's see an example in RStudio. Now I'll go ahead and create a vector again. So I'll name this vector as vec1, and I'll store all the elements from 1 to 9. Let me print out vec1 over here. So this is our vector, which would comprise of all of these elements starting from 1 to 9. Now, using the for loop, what I'll do is I'll add 5 to each of these individual elements. So let me show you guys the syntax. I'll type in for, and then I'll type I in vec1 print I plus 5. I'll copy this. I'll paste it in the console. So initially the value of I is taken to be 1. Now let's understand this for loop properly. So this for loop iterates till the end of the last element. Now let's understand this for loop properly. So for I in vec1, so initially the value of I starts at 1 and then it goes on till it reaches the last element. So it is 1, it comes inside the loop and 1 is added to 5, then the value becomes 6 and that is printed. And then again the for loop starts, the I value is incremented and I becomes 2. So 2 plus 5, it becomes 7 and that is printed. And then I's value is again incremented, it becomes 3, 3 plus 5 and then we have 8. So this goes on till the last element in the vector is reached. So the last element in the vector is 9. So 9 plus 5 becomes 14 and then we print it out. Now after that, if you try to increment the value of I, it will not be incremented because it has already reached the last element. So it will end when it is 14. So this is how the for loop works. Now let's work with the while loop. So it is sort of similar to the for loop, and it is also used to iterate something. But the only difference is it iterates a particular task till a condition is met. So now for this for loop, I'll actually use a counter. So I'll set I value to be equal to 1, and then I'll type while over here, and I'll type while I is less than 9. So this is the condition, and this loop will iterate till the condition is satisfied while I is less than 9, and I'll print out I, and then I'll print out I plus 5. After that, I'll increment the value of I with 1. So I becomes I plus 1. Let me copy all of this and let me paste it in the console. Right, so this goes on till 13 over here. So what is happening is initially I's value is 1. So the condition is checked over here. Is 1 less than 9? This is evaluated to true. So it comes inside the loop and 1 is added to 5, which becomes 6. So 6 is printed, and then I's value is incremented by 1. So it is 2. Again, it is checked inside the while loop. So is 2 less than 9? So if 2 is obviously less than 9, so it comes inside the loop. 2 plus 5 becomes 7. So I's value is incremented till it is 8. So 8 is less than 9. It is true. It comes over here. 8 plus 5 becomes 13, and then it is printed. But after that, when I's value is incremented, this condition fails because 9 is not less than 9. 9 becomes equal to 9. And since the condition fails, this loop ends over here. So this is how we can work with the for loop and a while loop to repeat a certain task. Now let's head on to the user-defined functions. So simply put, user-defined functions can be invoked to perform a specific task. So that task could be anything. So let's say you want to create a calculator. Now to create a calculator, you want to create individual modules. So you want one module which is used for addition purpose, one module which is used for subtraction purpose, one module for multiplication purpose, and so on. So over here, you can use functions. So you can create a function with the name add 5, which would basically take in a number and add 5 to it. So if you pass in 5, it'll be added with 5 and then the value becomes 10. And then if you pass in the number 10, this function will take in 10, add 5 to it, and then the result which you'll get will be 15. So this is how functions basically work. So functions basically are used to perform a specified task, and whenever you invoke the function, that task can be implemented again and again. And this is the syntax to create a function. So you will use the keyword function, and inside this you will pass in a parameter which is x, and inside the body you will type in what this function is supposed to do. So I'll type in print x plus 5, and I'll store this in an object with the name add 5. So I am basically creating a function which takes in a parameter and adds 5 to it and prints the value. I'll copy this and I'll paste it over here. Now let me type add 5, and inside this let me pass in 1. So the result is 6. Similarly, I'll type in add 5 again, and I'll pass in the value 10. So we get a result of 15, and then I'll pass in, let's say 100, and I get a result of 105. And this is how you can create a user-defined function. So these were some of the basic operations with the R language. Now we'll head on and see what exactly is data manipulation and how can we perform data manipulation operations with R. So let's take an example to understand data manipulation in a better way. So let's say you're given a huge data set by your manager, which comprises of around 1 million rows and 10,000 columns. Now your manager gives you a task of finding out all of the employees from this data set whose salary is, let's say, greater than $100,000 and age is greater than 50. So how would you do it? Would you actually manually go through each of these 1 million rows and check the age of the employee and salary of the employee? Well, obviously you wouldn't, right? So this would be a huge task, and this would also consume a lot of time. So this is where data manipulation operations comes in. So all you have to do is write in one simple line of code, and you can easily extract all of those employees whose salary is greater than $100,000 and whose age is greater than 50. And to perform data manipulation operations with R, we have the dpyr package. So this dpyr package is based on something known as grammar of data manipulation, and it makes the data manipulation task extremely easy. So let's again head back to RStudio and work with the dpyr package. So we'll be working with this laptops dataset to perform all of the data manipulation operations, and we've got all of these columns over here. Now let's see the number of rows and number of columns present in this dataset. So I'll type in n row over here and pass in the name of the dataset, which would be laptops. So see that there are 1303 rows or 1303 different types of laptops present. Now let me also check the number of columns present. So to check the number of columns, I've got the ncol function. And inside this, again, I'll pass in the laptops data frame. And there are 12 different columns present in this data frame. So there's a data frame which comprises of 1303 rows and 12 columns. Now let's look at the different columns of this dataset. So we've got the company or the brand name of the laptop. And then we've got the product name of the laptop. So if it's Apple, then what is the product name? It's MacBook Pro. Then we've got the type name. It's an Ultrabook. We've got the inches of the laptop. So what is the size of the laptop? So this Apple MacBook Pro, which is an Ultrabook, the size is 13.3 inches. Then we've got the screen resolution over here. Then we've got the CPU type. So over here, this laptop has basically Intel Core i5 with 2.3 gigahertz. And then the RAM of this laptop is 8 GB. Then we've got the memory of laptop over here. Then we've got this column which tells the GPU of this laptop. Then we've got the operating system of the laptop. So since this is a Mac laptop, the operating system is obviously Mac OS. And then we've got the weight of the laptop, and then we've got the price of the laptop in euros. So this Apple MacBook Pro costs 1339 euros. Right now my first task would be to load up the dpyr package. So I'll type in library and then I'll give in the name of the package, which would be dpyr. So this is how you load a package in R. So library of dpyr, and we have successfully loaded this package. Now before we load this package, you'd actually have to install this package. So to install the package, we've got this packages tab and we've got this install button over here. And inside this, you just type in the name of the package, which is dpyr. And if you click on install, the package would be installed. So I'll not click on install because I already have it installed over here. And I've also loaded up the package. Now I have already loaded the dpyr package and I have already loaded the laptops file. So to actually load a file in R, we'll be using this read.csv function. So let me just show you guys how this read.csv function works. So with the help of read.csv function, you can load a CSV file. And inside this, you'll just give in the path of the file over here. So this laptops.csv file is present over here. So inside this read.csv function, you'll just give in the path of the file. So this laptops.csv file is present in this path, D drive, slides and other files, Bharani, laptops.csv. And I'm storing it in a new object and I'm naming this object to be laptops. And to have a glance at the dataset, all you do is use the view function and then give in the name of the data frame, which is laptops again. Right, so this is a data frame. So we have successfully loaded this data frame. Now we'll go ahead and perform some data manipulation operations on this laptops data frame. So there's this select function from the dpyr package, which would help us to extract individual columns from the entire data frame. Now in this data frame, we see that there are not many columns, but consider a scenario where you have around 10,000 columns and you want to extract only 5 or 6 columns from all of those 10,000 columns. Now manually selecting those individual columns would be a Herculean task. So this is where select function comes into the picture. So let's work with the select function. So now what I want to do is I want to extract only the first column and the second column from this laptop's data frame. So this would be the way to do it. So I'll just type in the name of the data frame first, which would be laptops. And then we have something known as the pipe operator. So in the pipe operator, you give in the % symbol and then the greater than symbol and then the % symbol again. So this pipe operator basically helps you to connect an object with a function or one object with another object. So over here, what I'm doing is I am selecting the first column and the second column from this laptop's data frame. So I'll type in laptops over here and then I'll give in the pipe operator. Then I'll use the select function, which is part of the dpyr package. So if you have to use this select function, you would have to first load the dpyr package. And then inside this, you will give in the column numbers. And as we already know, the indexing in R starts with 1. So I want the first column and the second column, and I'm selecting these two columns from the laptop's data frame, and I am storing it in a new object, and I am naming that object to be, let's say, laptops 1, 2, Now let me open up laptops 1, 2. So this is my new data frame which I've extracted from my original data frame over here, which has all of these columns. So from all of these columns, using the select function, I have selected only the first 2 columns. Now similarly, let's say if I wanted all of the columns starting from the column number 3 going on till column number 6. So this is how I'll do it. I'll start off by giving the name of the data frame first, which is laptops, and then I'll give in the pipe operator, and then I'll give in the select function. So since I want a sequence of columns, first I'll give in the starting index of the column, which would be 3. So 1, 2, 3, which would be type name, and then I'll go on till column number 6. So 3, 4, 5, and 6. So I'm extracting all of the columns from type name, inches, screen resolution, and CPU, and I'm storing it in laptops 36, view of laptops 36. Right, so I have extracted all of these columns from the original data frame. Now similarly, I can extract the columns from this data frame on the basis of the names of the columns instead of giving them the index numbers. So if I want the columns company, product, and price euros, all I have to do is give in the column names inside the select function. So again, I'll start off by giving the name of the data frame, then I'll use the pipe operator to join the select function and the data frame. And inside the select function, I'll give in the names of the columns which I want to extract. Column. So I want to extract company, product, and the last column, which is basically price euros, and I'll store it in laptop CPP. So view of laptop CPP, right? So I've extracted company, product, and price euros from this entire data frame. Now there are 2 interesting attributes inside this select function. So let's say I want to select all of those columns with start with a particular letter or end with a particular letter. Then for this purpose, we've got the starts with attribute and the ends with attribute. So from this data set, I'd want to extract all of those columns where the column name starts with the letter capital P. So I'll select this code over here and I'll paste it. So from the laptops data frame, I am selecting all of those columns where the column name starts with capital P. So inside the select function, I'll use this attribute starts with, and inside starts with, I'll give in capital P, and I'll store it in laptops underscore P, view of. Right, so I have extracted these 2 columns where the name of the column starts with capital P. I've got product and I've got the price in euros. And similarly, I'd want to extract all of those columns where the name of the column ends with small s. So this time I'll be using the ends with attribute. So from the entire laptops data frame, I am selecting all of those columns where the column name ends with small s, and I'm storing it in laptop small s, view of laptop small s. Right, so I've got these 3 columns over here: inches, obs, and price in euros. So this is how the select function works, which is basically used to extract individual columns from the entire data frame. So after the select function, we've got the filter function. And with the help of the filter function, we can extract records from the entire data frame on the basis of a condition. So over here we have the first condition. I want to extract all of those records from this laptop's data frame where the company is Dell. Or in other words, I want to extract only the Dell laptops from all of the laptops present in this data frame. So again, I'll give in the name of the data frame, which is laptops, and then I'll give in the pipe operator. And after the pipe operator, I'll give in the filter function. So again, filter function is a part of the dpyr package. So if you want to use the filter function, you'd have to load the dpyr package first. And inside this, I'll give in the condition where company is double equal to Dell. So wherever the company is equal to Dell. So let me go over here, right? So wherever inside this column you see, if the value is equal to Dell, then we'll extract all of those records and we'll store it in a new object, and we'll name that object to be laptops Dell, view of laptops Dell. So if you have a glance at this column over here, we've got 297 entries in total, or in other words, we've got 297 Dell laptops from this entire 1303 laptops. Now similarly, let's go ahead and give another condition. So this time from all of the laptops, I'd want to select only those laptops where the size of the laptop is greater than 15 inches. So this is the command for it. I'll give in the name of the laptop, then I'll give in the pipe operator, and then I'll join this data frame with this filter function with the help of the pipe operator. And inside the filter function, I'll give in the condition, which is basically the inches needs to be greater than 15. So inches is basically this particular column over here, right? So inches needs to be greater than 15, and I'm storing it in laptops 15 inch view of laptops 15 inch. Right, so if you have a glance at this, we see that the inch is greater than 15 in all of these records over here. So there are 835 entries in total, or in other words, out of the 1303 records, there are 835 laptops where the screen size is greater than 15. And with the help of the filter function, we can also give in multiple conditions at the same time using the AND operator. So this time I want to extract all of those laptops where the company name is Dell and the inches is greater than 15. That is, I want all of the Dell laptops where the screen size is greater than 15. So laptops, the pipe operator, and then filter, I'll give in these two conditions. So the first condition is company needs to be equal to Dell, and after that I'll give in the AND operator, and then I'll give in the second condition, which is inches needs to be greater than 15. I'll store this in laptops Dell 15 inch. Right, so we have this column over here, company, and the company is Dell, and we've got the inches column, and we see that the inches is greater than 15. So there are 215 laptops where the company is Dell and the inches is greater than 15. Now we can also combine the select function and the filter function together. So when we combine these two, we can only select those columns which we want and only those records which we want. So let's perform this operation over here. So this is the first operation where I am extracting only the company column, the product column, and the price in euros column. And I am filtering out only those records where the company name is Dell. And I'm storing it in laptop final. So I'm just extracting 3 columns and only those records where the company name is Dell. So view of laptop final. Right, I've got only these 3 columns and I've got only those records where the company name is Dell. So let's understand this code in a better way. First, I'll give in the name of the data frame, which is laptops, and then I'll use the pipe operator. So with the help of this pipe operator, I am combining this laptops data frame and the select function. After that, I'll again give in the pipe operator and then I'll give in the filter function. So I am joining this laptops data frame with the select function and the filter function, and the final result is stored in laptop final. Now similarly, let me give in another condition. So this time I am selecting only the company column, product column, CPU column, and the RAM column, and I'm filtering out those records where the company name is Lenovo and the RAM is 4 GB, and I'm storing it in laptop final 2. So I've got these 4 columns over here, and these 2 conditions have also been satisfied. So the name of the company is Lenovo and the RAM size is 4 GB. So there are 89 records or 89 Lenovo laptops whose RAM size is exactly 4 GB. So this is how we can perform different data manipulation operations using the dpyr package. Now we are on to the final part of this tutorial, where we'll understand about data visualization and how to implement data visualization operations with the ggplot2 package. So let's again take the same example where you're given a huge Excel sheet which has a lot of rows and a lot of columns. Now, if you just look at the Excel sheet, you wouldn't be able to understand anything. But if you go ahead and make charts out of these Excel sheet, so let's say you make a bar plot or a histogram or a scatter plot for this Excel sheet, then you'd be able to interpret this data in a much better way. So this is exactly where data visualization comes in. So as I say, pictures speak more than words. And that is why data visualization is an extremely important part of the data analytics lifecycle. And to implement data visualization with R, we have this ggplot2 package. And again, ggplot2 is based on something known as grammar of data visualization. So as every language has grammar associated with it, and since visualization is also a form of language, even it has grammar associated with it. So to simply put, with the help of ggplot2, you can stack layers on top of each other. So first you start off with the data layer, where you basically choose what is the data you want to work upon. And on top of the data layer, you stack the aesthetics layer. So on the aesthetics layer, you basically map your columns onto different aesthetics. So you basically choose which column has to go onto the X aesthetic, which column has to go onto the Y aesthetic, and which column basically determines the color of these plots. Now, once you have the data layer and the aesthetics layer ready, then you have the geometry layer where you go ahead and build some geometries. Now, these geometries are basically the plots which you build. So let's say you have a histogram, a scatter plot, a box plot, or a scatter plot. Then all of these are the geometries. So first you start with the data layer, then you get to the aesthetics layer, and then you get to the geometry layer. So these are some of the basics of grammar of data visualization. Now let's go back to RStudio and perform some data visualization with the ggplotter package. So our first task would be to load up the ggplotter library. I'll type in library of ggplot2. And before again loading a library, we'd have to install it. So I'll click on this install tab, and then you just have to give in the name of the package, which is ggplot2. And when you click on install, the package would be installed. And we'll be implementing all of these visualization operations on top of the diamonds dataset. So view of diamonds, and we've got this dataset over here. Now let me check the number of columns and rows present in it. So ncol of diamonds. So there are 10 columns in this data frame. Let me check the number of rows. So n row of diamonds. And there are 53,940 rows in this diamonds dataset. Now let's understand about this dataset. So I'll just put in a question mark and I'll type in diamonds over here. So we see that this is a dataset which basically comprises of the prices and other attributes of almost 54,000 diamonds. And these are the different variables we have. So we've got the price column over here. So this is basically the price of the diamond in US dollars. And then we've got carat, which tells us the weight of the diamond, and it ranges from 0.2 to 5.01. Then we've got the cut of the diamond, which tells about the quality of the cut. So these are all the different levels which are present: fair, good, very good, premium, and ideal. Then we've got the color. So the diamond color varies from J to D, J being the worst and D being the best. And then we've got the clarity of the diamond. So clarity of the diamond is basically a measurement of how clear the diamond is. So L1 being the worst and IF being the best. Then we've got X, Y, and Z. So X, Y, and Z over here. X is basically the length of the diamond in millimeters, Y is the width of the diamond in millimeters, and Z is the depth of the diamond in millimeters. And finally, we've got the depth and the table columns over here. So depth is the total depth. So depth is the total depth percentage, and table is the width of the top of the diamond related to the widest point. So this is some of the description of the data set. Now let's go ahead and build some beautiful plots on this data set. So we'll start off by making a histogram. So with the help of a histogram, we can do univariate analysis. So what we'll do is, so what exactly is a histogram? So with the help of a histogram, we can do univariate analysis. So by univariate analysis, I mean that we can understand one particular column. And with the help of histogram, we can understand the distribution of a continuous column. So we've got these continuous columns over here: depth, table, price, X, Y, and Z. Now I'm going to go ahead and make a histogram for the price column. And this is how I'll do it. So this is the syntax for it. So ggplot, and inside this I'll give in the name of the data, which is diamonds. And then I'll map the price column onto the X aesthetic. And then I'll fit in the geometry, which is geom histogram. So I have successfully made a histogram for this price column. Now this syntax might seem too much, so let me actually break it down. So as I've told you, with the help of ggplot, you can add stacks on each other. So you'll start off with the ggplot command, and then you will give in the data layer. So you'll type in data, and then the data which you're working with is basically the diamonds dataset. So you have chosen your dataset, which is diamonds. I'll click on enter. Right. So you have basically started with your data layer, right? So this would be at the bottom. Now after this, you will choose your aesthetics. So you'll type in AES, and then I want to map the price column onto the X aesthetic. So I'll type in price, and I'm mapping this onto the X aesthetic. I'll hit enter. So I have successfully mapped the price column onto the X aesthetic over here. So you see that the price ranges from 0 and it goes on till about 50,000 over here. So we've mapped price onto the X aesthetic. Now it's time for the geometry layer. So now after the data layer and the aesthetic layer, if we have to add any more layers, we will use the plus operator and then add new layers. Now I want to add a geometry layer on top of this, and the geometry which I want to use is a histogram. So to build a histogram, we've got the geom histogram function. So geom histogram, and I'll hit enter. So now I've got everything. I've got the data layer, which is the diamonds, and then I've mapped the price onto the X aesthetic, and then the geometry which is used by me is geom histogram. Let me zoom this now. So this is a very beautiful picture, isn't it? And this shows the distribution of the price of the diamonds dataset. So if we have a glance at it carefully, we see that there are around more than 12,000 diamonds whose price would be not even 2,500 euros. And then when we come over here, so this is the price range of 5,000 euros. So there would be around 2,500 diamonds whose price would be 5,000 euros. Then we come over here. So this is the 10,000 price bracket. And this bar over here is again very, very small. So there would be not even around 100 or 200 diamonds whose price is 10,000. And when you come at this far end over here, right? So this is the smallest bar over here. So this would be the price of those diamonds whose value is greater than 18,000. So there are very, very few diamonds whose price is greater than 18,000. And these are some of the inferences which you can make with this histogram. Now let's go ahead and add some color to this. So this is the histogram which we have. Now inside this histogram, I want to add some color to this. To add the color, I would just have to use the fill attribute inside this geom histogram function. And the color which I want to add is green. Right, so I have successfully added the green color to all of the bars of this histogram. So this is the fill color. Now I can actually add a boundary color to all of the bins. And to add a boundary color, I have the COL attribute. And I'll set the boundary color to be equal to orange. Right, so I have added the fill color which is green and the boundary color which is orange. Now going ahead, we'll build a bar plot with the help of which we'll understand the distribution of a categorical column. So this is basically the difference between a histogram and a bar plot. So histogram is basically used to understand the distribution of a continuous valued variable, and a bar plot is used to understand the distribution of a categorical variable. Now we'll be building a bar plot on top of this cut column. So because we've got all of these different categories over here, and I want to understand the distribution of each of these categories. So again, I would follow the same procedure. I'll start off with using the ggplot function, and then inside this, I'll map the diamonds dataset onto the data layer, and then I'll use the aesthetic, and then I'll map the cut onto the X aesthetic. Then I'll add the geometry layer. And the geometry which we'd want to use is geom bar. So this is the bar plot which we've built for this cut column. I'll zoom this. So we see that there are more than 20,000 diamonds which have the ideal cut. And there would be not even 2,000 diamonds whose cut is ideal. And we've got around 12,500 diamonds whose cut is very good. And we've got around 13 to 14,000 diamonds whose cut is premium. Right, so obviously it's very easy when we actually build a plot. So now with the help of this graph, you can actually understand that visualization makes it very easy to understand the data. Now, if you are just looking at the data set, so let me open this data set over here, right? And if you just look at this cut column, then you would not have been able to understand this particular distribution over here. So with just one line of command, I was able to understand the distribution of this cut column. Now, similarly, let me make it more beautiful over here. So I'll add the color to this, and the color which I'll be adding to this is pale green 4. So I'll type in pale green 4 over here. I've added this fill color. Now, if I actually want the color of these bars to be determined by a column, then I can map a column onto the fill aesthetic. And over here, that is what I'm doing. So I have mapped the cut column onto the X aesthetic, and then I am mapping the same cut column onto the fill aesthetic. So this means that the fill color of these bars would be determined by the cut column. So this is the only difference. I'm using fill as an aesthetic rather than as an attribute. So if I put in the value of fill inside geom bar, then it will be taken as an attribute. But if I put in fill inside this aesthetic function, then it will be taken as an aesthetic. So now you see that each of these color is being determined by the different levels of this cut column. Right, so fair column is denoted with purple, then we've got good, very good, premium is denoted with green, and then we've got the ideal bar which is denoted with the yellow color. So this was a histogram and a bar plot. Now let's go ahead and create a scatter plot. So with the scatter plot, we can understand the distribution between two numeric columns. So how does one numeric column vary with another numeric column? And over here we are trying to understand how does the price of diamond vary with respect to the carat value. So let me type this out first. So I'll type in ggplot and I will and I will map in the diamonds layer onto the data aesthetic. And then I'll use the aesthetic layer and I'll map the price column onto the Y aesthetic. Then I will basically map the caret column onto the X aesthetic. And then since I have to create a scatter plot, I'll be using this geom point function. So this is our plot. We've got price mapped onto the y-axis and caret mapped onto the x-axis. So we see that the caret ranges from 0 to 5 and the price it ranges from 0 to around 18,000. And the inference is sort of clear. So as the caret value increases, the price of the diamond also increases. So this dot which you see, so this basically represents a diamond whose caret value is around 5 and the price of the diamond would be around $18,000. Then we've got this diamond over here again. So the caret value would be 4.5 and the price would be again around $18,000. Then we've got this diamond over here. So the caret value would be around 2.75 and the price of the diamond would be around 7,000 something, right? And we see that there is a greater distribution of diamonds over here. So throughout this data set, there are a lot of diamonds whose caret value ranges between 0 and 1 and their price ranges between 0 to 5,000. There is a greater density over here. And as we go to the right side of the graph, the density decreases. So there are very few diamonds whose price would be, let's say, greater than 12,500 and whose caret value is greater than 3. So you can actually count on your fingers the number of diamonds whose caret value is greater than 3. Now I'll go ahead and map the cut column onto the color aesthetic. So basically the color of all of these points would be determined by the cut column. Right, so the only difference is the color of the points is being determined by this cut column. So if you have a glance at these two diamonds, you see that the cut of these diamonds is fair. And you got a greater distribution of diamonds over here with the color yellow and green, right? So this bracket of the caret value being 0 and 1 and the price between 0 and 5,000, you see that there is a huge density of diamonds where the cut is ideal and premium. And you just did one minor change, which was adding this cut column onto the color aesthetic. Now we'll go on to the next type of geometry, which is box plot. So in box plot, we try to understand how does a numeric value change with a categorical value. And in this example, we are trying to understand how does the caret value of a diamond change with the clarity of a diamond. So again, the diamonds dataset has been mapped to the data layer. Then we've mapped the clarity column onto the X aesthetic and the caret column onto the Y aesthetic. And we're making a box plot for this. So the function to be used to make a box plot is geom box plot. And this is the plot which we have. So let me zoom this. So this is how a box plot looks like. Now let me explain these three lines over here. So this is the median line or the 50 percentile line. This is the 25 percentile line and this is the 75 percentile line. So if this median line tells you that if the clarity of the diamond is L1, then the caret value would be somewhere around 1.1 or 1.2. Similarly, if we take this particular box plot over here, this tells you that if the clarity of the diamond is IF, then the median caret value would be somewhere around 0.7 or 0.6. And all these dots which you see, so these are basically outliers. So this is basically one such outlier where the caret value is 5. So if you look at the general range of this caret value, then it would be around 0.2 or 0.3 over here, ranging to 2.2 or 2.3 over here. And all of these points that are about this line, all of these are outliers or anomalies. Now let me go ahead and add a color to these box plot on the basis of the clarity column. So I'm just making one minor change over here. So I am assigning the clarity column onto the fill aesthetic. So now each of these different box plots would have a different color. Now again, let me do something different. So now what I'll do is I will map the cut column onto the fill aesthetic. So now I've got caret onto the y-axis, clarity on the x-axis, and the color of these box plots is basically being determined by the cut column. And since the cut has all of these different levels, so we've got 5 different levels in the cut column, and for all of these different levels, we've got a different box plot. So this box plot is basically for that particular diamond where the clarity is L1 and the cut is fair. Then we have this box plot over here, which is for that diamond where the clarity is L1 and the cut is ideal. So let's draw some inferences from this graph. So if we take this box plot over here, then then we can infer that there is a diamond where the clarity is L1 and the cut is fair, then it would have the maximum caret value of 5. Now similarly, let's take this box plot over here. So the clarity is IF and the cut is ideal, then this would have a maximum caret value of around 2.2 or 2.3. So you can draw different types of inferences from this particular graph. Now we'll head on to the final part of this visualization, which is basically faceting. So if you actually look at this graph, then there are a lot of things which have been infused into one single plot. So what we'll do is, we'll divide this one single plot into multiple plots on the basis of one column or multiple columns. And over here, we are faceting or dividing this plot on the basis of the cut column. So there would be one subplot for the different types of cuts. So I am adding a new function over here, which is basically the facet grid column. And inside this, I'll give in the tilde symbol, and then I'll give in the name of the column on the basis of which these facets have to be made. So now we see that we've got 5 facets corresponding to the 5 different cuts. So this facet is for the cut value of fair, this is for good, very good, premium, and ideal. So one particular inference could be, so if you take L1 and fair, then we have the maximum caret value over here. Similarly, if we take the clarity to be VS2, then the maximum caret value would be for this diamond of the cut premium, right? Since this belongs to the premium cut. So again, when we facet our data, drawing inferences from this graph becomes extremely easy. Now we'll do one final thing when it comes to visualization. We'll see how to add themes to our plots. So we can actually add a theme to the panel and this particular plot. So I have the same command over here, and on this I'll add one more layer, which is basically the theme layer. And inside this theme layer, I would basically want to add a color to this particular plot. So I will type plot dot background equals, and then I've got different element functions over here. So if I want to make some change to a particular rectangle over here, right? So this plot is nothing but a rectangle. So I will select the element rect function, and inside this I will type in the fill attribute, and I want to add a color of, let's say, pale green 4 to this again. So I'll type in pale green 4. So I have successfully added this background color to this plot. Now this looks even more beautiful, doesn't it? Right? So this is how we can add a theme to our entire plot.
Now that we have learned all the basics of R programming, let's go ahead and work on a case study. So we'll be working on this Pokemon dataset, and on this Pokemon dataset, we'll be applying different data manipulation and data visualization operations. So our first task would be to load this dataset, and to load this dataset, we would have to use the read.csv function. So this is the command to load a file. So read.csv, and inside this I am giving the path of the file. So this is the path of the file, and I am storing it in a new object called as Pokemon over here. Now let me just have a glance at the dataset which I have just read. So I'll use the view method, and inside this I will pass in the name of the data frame. So the name of the data frame would be Pokemon, and let's see what do we have over here. So these are the different columns which are present. So we've got abilities, we've got against bug, against dark, against dragon. So these columns are basically how does the Pokemon perform against these primary types. So let's say if this is the Pokemon, I'm trying to understand how would this particular Pokemon fight against the bug type Pokemon, or how well can it fight against a bug type Pokemon. Similarly over here, if we take this, how well can this Pokemon fight against a dragon type Pokemon. Similarly, this will tell us how well can a Pokemon fight against a fairy type Pokemon. Then we have other columns. Let's go ahead and look at other columns. We've got the attack rating of the Pokemon. We've got the base X steps, the base happiness. We've got the capture rate, classification, what exactly, what class do the Pokemon belong to. And then we have the defense of the Pokemon. Then we have the experience growth. After that, we have the height of the Pokemon and the weight of the Pokemon over here. We've got height in meters. And then we have the HP. HP, you can consider HP to be sort of the strength of the Pokemon over here. And we've got the name of the Pokemon. This is the Japanese name. This is the name of the Pokemon. And we've got special attack, special defense, speed. Then we have type 1 and type 2. So type 1 over here would tell us the primary type of the Pokemon, and type 2 would tell us the secondary type of the Pokemon. So when we consider type 1 and type 2, this basically tells us that this is a grass poison sort of Pokemon. So primary type is grass and secondary type is poison. This means that primarily it is a grass Pokemon, but also it has some features of a poison Pokemon. And then we've got the weight column over here. Then we've got the generation column. This tells us to which generation does this Pokemon actually belong to. And we finally have the is legendary column. So this is legendary column would tell us if the Pokemon is a legendary Pokemon or not. So these are the different columns which are present in this data frame. Now let's go ahead and check how many rows and how many columns are present in this data frame. To check the number of rows, I would have to use the n row method. So I'll just type in n row, and inside this I will pass in the name of the data frame, which is Pokemon. And as we see, there are 801 rows in this data frame. Similarly, let me go ahead and check number of columns present. So I'll use the ncol method, and I will pass in the Pokemon data frame again. So now we get that there are 41 columns present. So in total, this is basically a data frame which has 801 rows and 41 columns. So now that this is clear, let's go ahead and do some observation with respect to the categorical columns. So categorical columns are basically which have categories in it which are not continuous. So we've got these three categorical columns. So we've got S legendary, generation, and type 1. And I am basically building a tabulation of the S legendary column. That is, I'd want to understand the frequency of different levels which are present in the S legendary column. So I'll just type in table, and inside this, first I'd have to type in the name of the data frame, which is Pokemon. I'll use the dollar symbol and select the column. So the column which I'd want to select would be is legendary. So 0 over here would tell us that the Pokemon is not legendary, and 1 would tell us that the Pokemon is legendary. So out of the 801 Pokemons which we have, 731 are not legendary, and only 70 of those Pokemons are actually legendary. Now similarly, let's go ahead and make a tabulation of the generation column. So I'll use table. First I'll pass in the Pokemon data frame. I'll use the dollar symbol, and then I'll select the column. So column over here would be generation. And as we see, we have 7 generations in total. And this is the maximum value. So the maximum Pokemons belong to the 5th generation. So 156 Pokemons belong to the 5th generation. And then the minimum value is for the 6th generation over here. So there are only 72 Pokemons which belong to the 6th generation. So this is quite an interesting observation, isn't it? So we have got to see the different or the number of Pokemons belonging to each generation over here. Similarly, I'd want to see the number of Pokemons belonging to each primary type. So I'll use table function over here again, and first I'd have to use the name of the data frame, which is Pokemon. I'll use the dollar symbol, and then I'll just select type 1, which is the primary type. So these are the different primary types. We've got bug, dark, dragon, electric, fairy, fighting, and so on. So as a kid, if you had watched Pokemon, or even if you are an adult, well, Pokemon was a very good series. So there's nothing wrong in watching Pokemon even right now. So you would know that these are the different primary types which are present in a Pokemon. Now that we know all of this, let's draw some inferences. So we see that the majority of the Pokemons belong to water type. So there are 114 Pokemons belonging to water type. Now, let's say similarly, we've got the steel type Pokemons. There are only 24 steel type Pokemons. The least seems to be of the flying type. There are only 3 flying type Pokemons. That is very, very less, isn't it? And if we talk about fairy, there are 18 fairy type Pokemons. So again, a very interesting observation over here. So now that we've looked at some categorical columns, let's do some inference on the numerical columns over here. So we had the HP column in the data frame. Let me just go ahead and show you guys the HP column. So let me just see. So here is the HP column. Now I'd want to find out the minimum value and the maximum value of HP. That is, there would be some Pokemon which would have the minimum HP value, and there would be some Pokemon which would have the maximum HP value. And I would want to understand what exactly are those HP values. So I just have to use the min method over here. And inside this, again, I'll just have to pass in the column. So Pokemon, I'd have to use a dollar symbol, and the column would be HP. So the minimum HP value seems to be of 1. Now similarly, let's check the maximum HP value. I'll use maximum, and again I'll use Pokemon dollar, and I would have to use the HP column again. And as we see, the maximum HP of a Pokemon is 255. That's quite interesting, isn't it? So minimum value is only 1 and the maximum is 255. So there's a huge difference between the minimum value and the maximum value over here. Now, similarly, I'd want to find out what is the minimum value of the speed of a Pokemon and what is the maximum value of the speed of the Pokemon. I'll just use min over here. And inside this, I'll pass in the name of the Pokemon of the data frame, which is Pokemon $, and the column is speed. Right. So it seems that there is one particular Pokemon whose speed is 5, and that is the minimum value of speed that can be possible. Similarly, I'll use max over here. And I'll give in the name of the data frame, which is Pokemon, and I'll select the column, which is speed. And we see that there is one particular Pokemon whose speed is 180, and that is the maximum speed possible. Right, so we've looked at these as well. Now we'll see if there are any missing values present in the data frame. To check if there are any missing values, we'd have to use the is.na method. So is.na tells us if there are any na values or missing values. So I'll just use is.na, and let's say I'd want to check this for the abilities column. So is.na Pokemon $abilities. As you see, we have a bunch of false values over here. So normally we will get a bunch of true or false values. So those bunch of true or false values would tell you. So let's say if there's a false value, that would mean that there is no NA. That is, the value is present. But on the contrary, if the value is true over here, so if you see any true, that would mean a NA is present over there. But as we scroll through all of these values, we see that all of them are false values and there are no NA values over here. So just to verify it, I can just sum up all of the values. So I would just have to use sum, and inside this, I'll pass in is.na, and inside this, let me just pass in the abilities column again. So I'll pass Pokemon $abilities, and as we see, it is 0. So there are 0 NA values present in the abilities column. So this is done. Now we'd have to rename some columns. So type 1 and type 2 are not really intuitive. So I'd have to rename the column from type 1 to primary type. So first I'd have to use call names. So this is the command which I'm writing over here. So I'll just go ahead and type call names. And when I type in the name of the data frame over here, let's see what do we get. So inside the call names method, when I pass in the name of the data frame, I just get a bunch of all of the columns which I have, right? So as you see, these are the 41 columns which are present. So I get the list of all of the names. Now, similarly, what I'll do is call names of Pokemon is equal to, I'll just pass in type 1. And when I do this, let's see what do we get. So you have a bunch of true and false again. So you have all of the false, you have true over here. So this true indicates, so now when you say call names of Pokemon, you get all of the column names of this data frame. And I want to check wherever the column name in this data frame is equal to type 1. And it seems that at this particular position, the name of the column is equal to type 1. So with this command, what I'm doing is, out of all of the column names, wherever the column name is equal to type 1, I'd want to change that column name to primary type. Right? So I hope this is clear to all of you guys. So let me write the entire command over here, call names. Inside this, first I'd have to pass in the name of the data frame. Then again, I'd have to use this parenthesis. So this parenthesis, inside this, I'll get a bunch of true and false values. So I'll use call names over here, and I'll pass in the name of the data frame again, and I'll use double equal to operator, and I'll set the column name to be equal to type 1. So this will give me a bunch of true and false values, and those bunch of true and false values I'm storing in this parenthesis. That would mean that wherever out of these values I have a true, in that case, I will go ahead and change it to primary type. So let me go ahead and change it to primary type. Right, now let me have a glance at this data frame view of Pokemon, and let's see if we have made the necessary changes. Let me go to the end of this. So as you see, initially the name of this column was type 1, and we have successfully changed this to primary type. Now, similarly, let's go ahead and change the column name of type 2 to secondary type. So we'd have to use a similar command over here. So I'd have to give in call names. Inside this, I'll pass in the name of the data frame, which is Pokemon. I'll give in parenthesis over here. Again, call names inside this, name of the data frame, which is Pokemon. And this time I am checking if the column name is equal to type 2. And if the column name is equal to type 2, I'd want to change it to secondary type. Now I'll go ahead and have a glance at the modified data frame again, just to verify if the changes have been done or not. Let me just drag this to the end and let's see what do we have. So as you see, initially this was named type 2 and we were able to change the name of the column from type 2 to secondary type. This is done as well. Now we will also go ahead and change the name of the column of this. What you see, we have a column called name and I'd want to change that to Pokemon name. That is also very simple. We'd have to perform a similar command over here. We'd have to use call names. Inside this, I'd have to pass in the name of the data frame, which is Pokemon. I have this parenthesis over here. I'll use call names. I'll pass in the name of the data frame, which is Pokemon over here. And I'll check if this value is equal to name. And if it is equal to name, I'll just go ahead and I'll change the name of the column to Pokemon name. View of Pokemon, and let's see what do we get over here. Let me go to, let's see if we can find it. So as you see, initially this column was called as name, just name, and we have changed it to Pokemon name. So this is how we can go ahead and change the name of a column as well. Right, so now that we've done all of this, we've done some basic pre-processing. We've looked at the different categorical columns. We've looked at some variation of the numerical columns. We've seen if there are any missing values, and we've also gone ahead and renamed some columns. Now it's time to do some data manipulation. So from this entire Pokemon data set, I'd want to extract only grass type Pokemons. That is, from the entire data frame, I'd want to select all the records where the primary type is equal to grass. So let me go ahead and write the command for that. So first I'd have to go in and give in the name of the data frame, which is Pokemon. Then I'd have to use the pipe operator. So I'll give in pipe and I'll use the filter function. So this filter function is actually part of the dpyr package. So before writing this command, I'd have to load the dpyr package. I'll write library of dpyr. Now that we've loaded this, let me go ahead with the command. Pokemon is the data frame. And from this Pokemon data frame, I am using the filter function so that I can extract all of those records where if the primary type is equal to grass. So with the help of this filter function, I'm giving the condition, and the condition is primary type of the Pokemon needs to be equal to grass. And wherever that condition is satisfied, or whichever records satisfy those condition, I will select all of those records and I will store them in an object called as grass Pokemon. Now let me have a glance at this new object called as grass Pokemon, and let's see what do we get over here. Let me go to the primary type column. So as you see, we have all of these different entries, and if you look at the records over here, all of them are grass. So as you see, all of them are just grass over here, right? So we have done this as well. Now that we have created this new object called as grass Pokemon, I'd want to analyze some features of this grass Pokemon which I've just created. So I'd want to find out the minimum speed of a grass Pokemon. So I'll use the minimum method. So we already work with this. And now the name of the data frame would be grass Pokemon. I'll use the dollar symbol and the name of the column would be speed. So as you see, the minimum speed of a grass type Pokemon seems to be 10. Now let's go ahead and also check the maximum speed of a grass type Pokemon. I'll use the max method over here. And inside this, again, I'd have to pass in the name of the data frame, which is grass Pokemon, and I'd have to select the column. So the name of the column would be speed. So it seems that the maximum speed of a grass type Pokemon is 145. So I'll just go ahead and add a comment over here so that I can compare it with the other type of Pokemons which we'll be extracting later. So minimum speed value of a grass type Pokemon is 10, and similarly the maximum speed value of a grass type Pokemon is 145. So this was the minimum and maximum value of speed. Now similarly, let's go ahead and find out the mean value of special attack and special defense for a grass type Pokemon. So I'd have to use the mean method, and the data frame would be grass Pokemon. I'd have to select the column. So first I'd want to find out the mean of special attack. So it seems that on an average, a grass Pokemon would have a special attack of 74. So similarly, let me find out the average value of special defense. So I'll use mean over here. Again, grass Pokemon. And this time I'd want to find out the average of special defense. So it seems that on an average, the value of special defense for a grass Pokemon seems to be 69. So again, I'll add a comment over here. Again, I'll use hash, and the special attack is 74. And similarly, I'll use hash over here, and the special defense is 69. Right, so I have done some basic inference over here. Now I'll go ahead and make some plots on this grass type Pokemon. So to make some plots, we'd have to use the ggplot2 library. I'll just type in library and load the package. So the name of the package is ggplot2. We have loaded this. Now I'd want to understand the distribution of HP for a grass type Pokemon. So first I'd have to use the function ggplot. I'd have to map the data frame onto the data aesthetic. I'll use data over here. I'll be mapping the grass Pokemon onto the data aesthetic over here, or the data layer over here, and I will use the aesthetic. And inside aesthetic, I will just be mapping HP onto the X aesthetic. So I have HP and I'm mapping HP onto the X aesthetic. And the distribution or the plot which I want to make right now is geom histogram. So let me just go ahead and write in the name of the method, which is geom histogram. So this is what we get over here. So it seems that this is the maximum value. So this would be around, let's say we call it around 60. So this value of 60 or 65. So there are around 12 Pokemons. You can say there are around 12 Pokemons whose HP is 60. Similarly, if we take this, it seems that there is just one Pokemon whose HP is close to 120. If we take this value over here, there is only one grass type Pokemon whose value is very low. It is around 20. It's somewhere between 25 to 30, if we can say. And again, if we take this bar over here, so there are around 10 Pokemons whose HP is equal to 75. So again, these are some sort of inferences which we were able to make with the help of this histogram. Now I'd want to go ahead and add some color to this. To add a color, I'll be just using the fill attribute over here. So I'll just use fill, and inside this I will pass in the name of the color, which is pale green 4. So as you guys see, we were successfully able to add color to this particular histogram over here. Now similarly, we will go ahead and make a histogram for the height of the grass type Pokemon. So I'd want to understand what is the variation in the height of the grass type Pokemons. So again, ggplot, and I'll be mapping the Pokemon data frame onto the data layer, because that is the data which I'm working with. And I'll start with the aesthetic layer. I'd have to map the height onto the X aesthetic. So the name of the column is height M, and again the geometry used by me is geom histogram. So I'll just type in geom histogram over here, and let's see what do we get. Let me zoom this over here. So as you see, most of the Pokemons, so there are more than let's say 250 Pokemons whose height is very, very less. So their height would be somewhere around, let's say 1.5 or 2 meters. So seems that the grass type Pokemons are not very tall, and there is just one Pokemon whose height is close to around 14 meters or 13 meters. And over here, let's say you have around two Pokemons whose height is around 9 meters, and you have around one Pokemon whose height is 8 or 7.5 meters over here. Right, so this basically tells you most of the Pokemons, their height would be somewhere between 1 to 2 meters if they are of grass type. An interesting observation over here. Similarly, I'd want to understand the distribution of the weight of these grass type Pokemons. So again, ggplot, and onto the data layer, I'll be mapping the Pokemon data frame, aesthetic layer again, and onto the x-axis. This time I'd have to map the weight column, so I'll just type in weight kg over here, and the geometry used by me is again geom histogram. So let me just type in geom histogram, and I'll give it a color. So let's say the color which is given by me is coral. So seems like we have an error over here. Mapping must be created, weight kg. So let me just go ahead and check what is this error over here. Data is, have I given this equal to properly? This seems to be fine. Aesthetic weight is kg. Let me make this capital kg. Let's see what is the error over here. So let me just go ahead and write the command again. So I'll just type ggplot over here, and data would be grass Pokemon. So let me just pass in the data over here. I'd have to use the aesthetic. So over here onto the x-axis, I'd have to pass in the weight. So this will be weight in kg. And I'd have to use a geometry now. The geometry will be geom histogram. Let me just use geom histogram over here. So you have successfully created this. Let me go ahead and add the color, which is coral. So this was the mistake which we had did. So we just had to use the fill attribute. So fill is equal to coral. Right, so as you see, we have successfully assigned this color called as coral to this particular graph over here. And as we see for most of the Pokemon, so if it is grass type, there are around 25 Pokemons whose weight would be, let's say, around 10 kgs over here maybe. And there are around 5 Pokemons whose weight is would be around close to 100 kgs or exactly 100 kgs. And there is one Pokemon whose weight is 200 kgs. And there is one Pokemon again whose weight is more than 300 kgs. So again, interesting observations over here which we get from this. So now that we've done this, what I'd want to do is I'd want to understand how many legendary Pokemons are there when it comes to the grass type Pokemons. So for this, I'll be making a bar plot. So ggplot, and I'll just use data over here. And again, I'll map the grass Pokemon onto the data layer. And inside aesthetic, I would have to map the S legendary column onto the x-axis. Let me give in the name of the column, which is S legendary, and the geometry used by me is geom bar. So I'll just use geom bar over here, and I'll give in a color. So let's say the color which I'll give over here this time is blue. Right, so as we see over here, there are very few legendary Pokemons when it comes to grass type. But when it comes to non-legendary, so as you see, there are, or you can say most or 95% or even 98% of the Pokemons are not legendary when they're of grass type. So this count would be, let's say, around 3 or 4 or even less than that. So there are very few Pokemons who are actually legendary when it comes to grass type. Right, so this was an interesting observation again. So as we had extracted all of the grass type Pokemon, similarly we will go ahead and extract all of the fire type Pokemons. So first I'll have to give in the name of the data frame, which is Pokemon. I'll use the pipe operator, and using the pipe operator, I'll use the filter method. So from this Pokemon data frame, now I'd have to give in a condition. So the condition is wherever the primary type is equal to fire, I'd want to extract all of those Pokemons. And once I extract them, I will store that in an object called as fire Pokemon. Now let me have a glance at this, which I've just created. So view of fire Pokemon. Let me see what I have over here. Let me go to the primary type. So as you see, we have 52 entries, and out of these 52 entries, when we look at the primary type column, all of them are fire type. So we have successfully extracted all of the fire type Pokemons from this entire data frame. Now I'd want to find out the minimum and maximum speed of the fire type Pokemons to compare the speed with the grass type. So I'll use the min method. I'll use the name of the data frame, which is fire Pokemon, and select the column, which is speed. So it seems that the minimum speed of a fire type Pokemon is 20. So let me add 20 over here. Now let me go ahead and compare it to the grass type. So it seems that the minimum speed of a grass type Pokemon is 10, but the minimum speed of a fire type Pokemon is 20. So this is an interesting observation. Similarly, let me go ahead and also find out the maximum speed. So I'll just use the max method over here, and it seems that the maximum speed of a fire type Pokemon is 126. So let me go up over here. So when it comes to grass type, it is 145. So there is one grass type Pokemon whose speed is 145. But when it compared to fire type Pokemon, seems that we don't have any fire Pokemon whose speed is close to 145 or above that. So let me add a comment over here. So the maximum speed of a fire type Pokemon is 126. Now that we have done this, I'd also want to look at the mean special attack and mean special defense. Mean of and name of the data frame is fire Pokemon. I'd want to find out the SP attack. So it is 87. Let me just add 87 over here. And also let me go ahead and check the special defense. So mean of fire Pokemon, I will just make it special defense over here, and the value of this is 71. So let me make it 71 over here. So let me compare it with grass type again. So average special attack and special defense is 87 and 71. So when I compare it with grass type, so it seems that fire type Pokemon has a higher, or on an average, fire type Pokemons have their special attack and special defense to be higher than grass type Pokemons. So this is again very interesting to know over here. So now that we've done this, we would have to go ahead and visualize some patterns when it comes to fire Pokemons. And for that purpose, I'd have to use the ggplot library. So I'll use ggplot, and this time what I'd want to do is I'd want to understand how many of the Pokemons belong to different generations. So what is the frequency of the fire type Pokemons with respect to generations? So ggplot data, and I'm mapping the fire Pokemon onto the data layer. Then I have the aesthetic layer, and I am mapping the generation column onto the aesthetic layer. On the X aesthetic actually, so I'll just set generation is equal to X. Then I'd have to set the fill as well. So I'll set fill is equal to as dot factor, and inside this I will pass in the name of the column, which is generation. That is, I'd want the color of all of the bars to be determined by the generation column over here, and obviously the geometry which is being used by me is geom bar. So I just use geom bar over here, and let me hit on enter, and let's see what do we get. So as you see, we have 7 generations of fire type Pokemons, or in general there are 7 generations. And so most of the fire type Pokemons, they belong to generation 1. So there are around 11 Pokemons who belong to generation 1, and it seems that this is the minimum value over here. So there are only 4 fire type Pokemons which belong to generation 4 over here. There are only 5 fire type Pokemons which belong to generation 4. Similarly, if we take this, there are only 5 fire type Pokemons which belong to generation 7. So this we were able to understand by building a bar plot. Now let's see what is the next type of visualization which we'd have to make. So now we'd want to understand what are the different secondary types for the fire type Pokemon over here. So ggplot, and onto the data layer I'll be mapping the fire Pokemon, and I'll be using aesthetic over here, and I'll be mapping the secondary type onto the X aesthetic. Let me just use secondary type over here. I'm mapping secondary type onto the X aesthetic, and then I'll use fill. So again, basically the color of the bars would be determined by the secondary type column. So I'll set the fill to be equal to secondary type as well. And once that this is done, all I have to use is make a bar plot. So let me just use the geometry, which would be equal to geom bar. And this is what we have over here. Let me go ahead and add a color. So as you see over here, so fill, it has to be, I'll just make it as dot factor over here. And let me pass it inside as dot factor. Let me cut it. Let me paste it over here. Now let me run this. So we'd have to put this inside the aesthetic layers. So that is what the error is over here. Let me cut this entire thing from over here, and let me paste it inside this. And now let's go ahead and click on run, and let's see the result. Right. So as we see, these are the different secondary types for a fire type Pokemon. And it seems that so this is basically we don't have a value over here. So it seems that they are like genuinely fire Pokemons and they don't have any secondary type. So after that, if we look at these two, so this basically indicates flying type. So there are so the majorities of those fire type Pokemons whose secondary type is flying, and then similarly it seems that most of the fire type Pokemons can also be fighting type Pokemons. Then we have these three, so we have ground, ice, and normal. Then the next are like very very small. It seems like there is only one Pokemon. So it seems like there is only one or two Pokemons whose primary type is fire and whose secondary type is steel and water. So this is actually very intuitive, isn't it? So you can't really have a Pokemon whose primary type is fire and whose secondary type is water. So that doesn't really seem to be possible. Right, so now that we have done this, let's go ahead and make another visualization where we are trying to understand what is the difference between the special attack and special defense of the fire type Pokemon. So for this purpose, we'll be making a scatter plot. So let me type in ggplot over here and I'll be mapping fire Pokemon onto the data. Let me use the aesthetic layer now and I'll be mapping special attack onto the x-axis. Let me just type in SP attack over here and then onto the y-axis, I'll be mapping SP defense. Now let me go ahead and use the geometry. So the geometry which I'll be using now is geom point, and let's see what do we get. So it sort of seems like there's a linear relationship, if you can call it. So if the special attack of the Pokemon increases, the special defense of the fire Pokemon would also increase. Right, so sort of an interesting observation over here, right? Or you can even put it this way. So if a fire type Pokemon has a high special attack, then it would also mean that the fire type Pokemon would, there's a greater probability for the fire type Pokemon to have a higher special defense as well. So this is sort of the inference which you can make from this. Now what we'll do is we will go ahead and make a plot of weight versus height. So again, we'd have to make a scatter plot. So ggplot onto the data, we'll have the fire Pokemon, and in the aesthetic layer, we'll have height m mapped onto the x-axis. So x would be equal to height m, and onto the y-axis, we'll be mapping the weight. So weight kg, and let me go ahead and use the geometry. So the geometry would be geom point. And let's see what do we get over here. So this is point, not point. Right. So again, sort of as you see, if the height is increasing, the weight is also increasing. But then again, you can't really say that this is a linear relationship. And if the height is more, the weight is also more. So you can't really say there is a direct relationship between height and weight. But sort of, you can say there is a slight probability that if the fire type Pokemon has a very good height, then it must also have very good weight. Right, so if you look at this over here, so it seems that the height of the Pokemon is very large, right? So it would be around, let's say, close to 4 meters would be the height of this fire type Pokemon over here, but the weight of the Pokemon is very low. Similarly, if we take this point over here, so again, this is an outlier where the height of the Pokemon would be, let's say, around 1.75 meters, and the weight of the Pokemon is more than 400 kgs, right? So we've got two outliers or anomalies over here, but this is the general trend. This general trend tells us that the height of a fire type Pokemon would normally range between 0 to 2 meters, and the weight would normally range between 0 to around 200 kgs. So interesting observation over here again. With this, we've come to the end of this session. Now let's have a quick glance at the summary. So we started off by installing R and RStudio in the systems, and then we looked at some basics of R. After that, we looked at the different data structures in R, following which we work with some inbuilt functions, flow control statements, and user-defined functions. And then we work with the dpyr package to perform data manipulation. And then we also work with the ggplot2 package to perform data visualization. And then finally, we worked on a case study on the Pokemon dataset. So thank you guys for attending this session. And before I end this session, I'd like to inform you guys that we have a free learning platform called as Great Learning Academy, where we offer more than 80 plus courses with respect to different domains such as artificial intelligence, machine learning, cloud computing, and so on. So the link for which will be available in the description. You can go ahead and check it out. Thank you guys and have a great learning ahead.